Alright, this is the video where I'm going to try to reteach elimination, looking for the easy times to use elimination versus when it's a little tougher. First problem should be an easy one. We're going to look at x plus y equals 8, x minus y equals 4. And remember, the key to when to use elimination is most of the time if everything's lined up, x's, y's, equal signs, numbers, that's a good time to use it, especially if you have opposites or same, which we have both here. When you have opposites like we do with y and negative y, you can add. And what happens is this is 1x and 1x, which makes 2x. Y plus negative y cancels, that's why it's called elimination. 8 plus 4 equals 12. Divide by 2. X is 6. Very quickly we figured out that x is 6. Then we would just go to one of the equations, like the top one, x plus y equals 8. We now know that x is 6, so 6 plus y equals 8. Subtract 6. We know that y is 2. The answer to this system is 6, 2. Now I added because the y's were opposite. Some of you may have wanted to subtract because the x's were the same. You'll see that in the next example how that works. But yes, you could have subtracted. You just would have found y first instead of x first. So number one, everything lined up, opposites, add them up, do the work. 6, 2. Number two, 5x plus 3y equals negative 13. Sorry. And 5x plus 8y equals 7. All right, so again, everything's lined up. We don't have any exact opposites, but we do have 5x and 5x, which are the exact same, which means instead of adding, you can subtract. That eliminates the x's, which is what we wanted. You just have to be careful when you're subtracting. 3 minus 8 is actually negative 5y. Negative 13 minus 7 is actually negative 20, and so some people have trouble when they subtract. But it wouldn't take you very long to get that y is 4. And then we go back to one of these equations like the first one. We now know that y is 4, which makes that come out to be 12. And then we move this 12 by subtraction. And all of this is just algebra, that's why I'm going fast, because that's the part you ought to know how to do already. But after a little bit of work, you figure out that your x value is negative 5, your y value is 4. So on example 1, we added because we had opposites. Example 2, we're subtracting because we have numbers that are the same. The whole goal is what we've been trying to do over and over, get down to one equation with one variable. Number 3 is the first time where we're going to have to use the multiplication, because if you look at the original system, there are no coefficients that are the exact same or that are exact opposites. So this is one where you need to decide what variable you want to get rid of. For instance, let's say that you recognize that if I multiplied the top one by 3 and the bottom one by 4, that you could get some 12s to cancel out. And again, different people do it different ways. You could have used 7s and 2s to get rid of the x's instead of the y's. But if we distribute all the way through, we would get, for the first equation, 6x minus 12y equals negative 39. For the second equation, 28x plus 12y, which is what I was hoping for, and negative 44. I'm just double checking my math for a second. 6x, 12y, negative 39. Oh, we have a problem here. So I'm going to go back a second. Sorry. Wrote the problem down wrong. It is 2x minus 4y, but it's negative 8. It is 7x plus 3y and negative 11. Now the reason I want to make sure we're using the right numbers is so that we get nice clean answers without any decimals today. Not that decimals are bad, but just trying to give you some answers that you can actually feel good about. All that's really going to change is this will be 6x minus 12y equals negative 24 instead of where I had negative 39. And this one will still be 28x plus 12y equals negative 44. So the only number that changed is here because I wrote this number down wrong. All right, we can add since we have opposites. We get 34x. We get elimination. We get negative 68. Divide by 34, divide by 34. X is negative 2. And if x is negative 2, then we go back to that top equation, 2x minus 4y equals negative 8. We now know that x is negative 2. We get negative 4 minus 4y equals negative 8. Add the 4. We get negative 4y equals negative 4. Divide by the negative 4. After a little bit of algebra, we get y equals 1. The answer to this system is negative 2, 1. So the only error is when I wrote down the original problem with a 13, which was in the previous problem. And that's what I did. I jumped to the wrong problem. So be careful. Make sure you're writing the problems down. Those of you who've been watching my videos, that's the only mistake I've made is a couple times I've written the problem down wrong, which of course yields a wrong answer. All right, last problem for elimination. And we'll call this our star problem because a little tougher. We have y equals 9x plus 23. X minus y equals 1. This is the first time I've given you a problem that's not lined up. But it's really not that bad. If you will subtract 9x over to the other side, the top equation would become negative x plus y, and the 23 would still be over here. So just by moving the 9x, I now have a problem that's lined up and a problem that has exact opposites. So I could just add. We'll go to the back first. 23 and 1 makes 24. The y's cancel. X and negative 9x is negative 8x. Divide by negative 8. X is negative 3. Let's go to the second equation where we had x minus y equals 1. And we now know that negative 3 is x. We would add 3. Negative y equals 4, but we don't want negative y, so we divide by negative 1. We get y equals negative 4. So the solution to this system. So if you go back and look through the problems, we had one that was an easy add, one that was an easy subtract, one where we had to multiply both equations through by a number to get those opposites, and this last one where we had to move to get it lined up, but then once we did, we had an easy elimination situation. So that's all for elimination. Next, I will approach a problem and ask whether it lends itself better to elimination or substitution.